Hey everybody, I'm Ranj, the bearded plumber from Amsterdam. Thanks for joining me today in today's video. Today's video is basically about a job I did this week. Monday evening I got a call from a customer, well, a WhatsApp message. That's how I run my business, via WhatsApp and text messaging. But anyway, the customer contacted me on the Monday evening saying that they have a Vaillant water heater and he doesn't have hot water, obviously. So it's not going to give central heating, it's a water heater. The normal Vaillant water heaters I work on a regular basis are two types. The first one is normally open flued, and the second type is a balanced flue fanless, or a fanless balanced flue. Fanless balanced flue, yeah. Anyway, you know what I mean. A balanced flue where it draws the air in through the air intake pipe in the flue and then pushes the air out through natural draft without the aid of a fan. So this is what I normally work on. So I attended to the property with what we have. What this appliance has is a spark generator, which is usually battery operated because obviously there's no fans. It works with a battery. As the water goes through the flow turbine, the flow turbine usually spins, causing a small electrical charge for the battery in the generator to realize and recognize that there is a demand for hot water, and it fires the boiler up. However, this one I attended to was one of the newer versions. It's a fan assisted balanced flue water heater, and the issue here was that it was saying on, and when you put the hot water tap on, it didn't want to do anything. So I knew it was a flow switch, only that I expected it to be a balanced flue version without a PCB and without a fan. So anyway, I went to the job on Tuesday, diagnosed the issue, and then I went back on Friday, which was yesterday, the 28th of May, and I got it up and running just in time for the weekend. As you all know, it's gonna be great weather going forward, which means you're gonna probably need to shower more, but no one wants to shower with freezing cold water. So therefore it was just a perfect timing. I got the job done in time for the weekend, and the video shows how I diagnosed the fault and how I repaired it. Stay tuned, check out how I did the job, and you know, if it's something new to you, at least you can learn something from it. And if you already know, you know, leave your comments below how you would have done it different. We're all here to learn from each other. The one thing that I did notice in this water heater was that the flow switch or the flow turbine was, I would say, almost identical to the one in the Ecotech. So yeah, going forward I will keep an Ecotech flow turbine in the bearded hot rod in my van stock, so that should I ever face this sort of problem, either on an Ecotech combi or one of these newer water heaters, because from what I have found out, these water heaters are now selling quite well, as they are able to deliver amazing flow rates for a water heater alone. So therefore it's going to be a good idea that I keep the stock in my van at all times with me. So yeah, let's get on with it and see you in the video. So this is a Vaillant water heater, instantaneous water heater, and it's powered on, as you can see, but when we put the hot tap on, nothing. It's not responding at all. No response. So I have diagnosed the problem, and I've come back with the part today. The part is the flow turbine. This is what's faulty, and I will show you how I diagnosed it to be this component and not something else. The first thing I did was, so when you turn it off, it says there's nothing on the display. So when you turn it on, so you can hear the fan is running. So inside this appliance, all there is a fan, gas valve, obviously a flow turbine, and a little PCB to recognize. So basically the way it works is water goes in to the water heater, hits the flow turbine senses water is in demand, tells the signal back to the PCB to fire up, and then you know the rest. Gas valve comes on, air pressure switch makes, and ignition occurs. So the way I diagnosed it was like so. Give me a sec, let's take this boiler apart, or water heater apart, and show you how I did it. So it's all Torx 20 screws holding it together. So first of all, let's turn it off. Right, that's out of the way. So this here, just behind here, that's the flow turbine, there it is. So there, can't get a better angle. Well, behind this brass thing, that's where the flow turbine is. So this clip here is what's holding the turbine in place. So the way I diagnosed it was as so. Let me get the PCB cover off. And then I got my little multimeter out, the Regin One Touch. I'm sure you can see that. So, what I first did was I took the cable, the Molox plug. So here's the Molox plug that fits on the flow turbine. And I wanted to find out which cable, the J2 jumper, or the J2 switch connection, because obviously it's the only one that's got pink, grey and white cables going to it. But to make it more interesting, there's 2 whites, 2 greys and 2 pinks on the same J2 connection, which is a bit annoying. So what I did was I removed it, like so, put it to the grey, and then here to a grey, and I had continuity. I went to the other grey, that's also on the same connection, and then went back to here, no continuity, it's like in mega ohms. So that's confirmed that this grey from the flow turbine is the grey over here, which then obviously led me to believe that the white and the pink next to it has to be the white and pink here, but obviously I did do the test and confirmed that. Then I pushed this connection back on, but not fully home. So it's on, the teeth of the connections are definitely making good contact. I put the flow sensor connection back on. I then powered it back up. So again, the fan spins, which tells me the fan is working, it's getting power to the fan. That's good. I'll wait for that to stop. Okay. Now, taking my multimeter, I just touch the connections on the PCB where the flow turbine is, and as you can see, let me turn it around. Between the grey and the white, I'm getting about 17.5 volts. Between the grey and the white, I'm getting 14.5 volts. Between the white and the pink, about 3 volts. I keep saying ohms. 3 volts. To be honest with you, do not know what the voltage should be. I know it should be around about 20 volts because obviously it's low voltage. So what I did now was I turned the hot water tap on. What I'm expecting is this voltage here to change. So with the tap running, this is still 17.5 between grey and white. And between grey and pink, it's still 14.5. And between white and pink, still 3 volts. So no change. So this confirmed to me that the flow turbine is not detecting the water flow, hence why the voltage on this connection is not changing. So I went and got myself a new flow turbine. Don't need that. Just here, new flow turbine. Now, the hard bit of the job is to change it because the cold water stopcock in this property is very hard to access. This is why I brought the wet vac with me. So first of all, let's unplug this appliance. Yep, it's definitely dead. Perfect. So this here, back there behind the gas valve, there's an isolation valve which doesn't work too well either. So the best I can do is try to isolate as much as I can. Not the best of jobs, I'm telling you that much now. This is going to make a bit of mess, I know it will. So that's being turned what should be 90 degrees. And as you can hear, the water is still slightly flowing. Ever so slightly. I do believe, however, that this isolation valve is probably working and it's a backfeed from a shower valve or somewhere. Because this has turned 90 degrees definitely all the way. So I'm 99% certain it's a backfeed. But to get me out of trouble, what I've gone and done is a bit of pre-planning. I bought a boiler fix valve. I've grinded this side down with a file so that I can remove this flexi off here. I'm going to PTFE tape this and a bit of Boss White, screw this into this 1/2 inch socket, like so. And then this side, I'm going to Boss White it. And we'll see, when I undo this, if it is a backfeed, I should be lucky and I should be able to work with a bit of peace in mind that I can stop the water with this isolation valve. If the water is still coming through this isolation valve, I'll just have to Boss White this and then just tighten it and pray, really. So yeah, it's all I can really do. Because I'm in a block of flats and we can't turn the water off to the whole building without getting involved with the whole building maintenance company. And worst case scenario, I've got my wet vac with me as well. So let's turn that tap off for a minute because it's really annoying while I prepare all this. So just PTFE tape around this thread. I'm going to be generous, I'm not going to lie, be generous with the PTFE tape. Then we're going to just screw this in together like so. Okay, so that's screwed in all the way, as you can see. I want to just clean the inside of that now. There you go, clean. So now, the tap is already isolated. Let's have that ready there. Let's just apply a nice helping of Boss White into the thread here. Okay, so that's ready just here. Wet vac is on hand as well. Let's see what happens. Oh wow. Okay, so I may be over panicking, but it's better to be over ready than not ready at all. So as you can see, the water's all isolated. And oh, there is a backflow, there you go. So hot is on here. And watch this. And watch this. When I turn the tap off, it comes out of this flexi. So this flexi is a cold in. And it's coming out of here, which means obviously it's backfeeding somewhere. Could be the shower valve, could be one of these mixer taps that's passing. At least I can work. So what I'll do is I'll just screw this back on and keep this in the van for a future job. So that was not needed here, thank God. That means the job's going to be a lot quicker than I expected. So I've left the tap running because if I turn the tap off, obviously the water will start pissing out the flow switch. Okay, so now let's open this up. And just for now, I'm going to put the PCB cover back on. Because the last thing I want is to fucking flood the PCB. Let's get down to business. I'm going to remove the connection to the gas valve, just so it comes out, get it out of the way. And okay, all the cables are out of the way. Trusty long nose pliers. That's quite annoying, I can't get that out so easily, so I'm going to undo the gas. Okay, out the way. And now the retaining clip comes out. Cold water over here also has a union I can undo. Oh, okay. For this reason I did bring my flexi black bucket. That's fine. Okay, there we have it. Flow turbine out. Flow turbine is out, guys and girls. Mainly, guys, I've noticed in my stats on YouTube, my audience for women is next to nothing. I think I have like 1% female, that's probably my mother-in-law. That O-ring goes there. A bit of silicone grease. Quite a bit, actually. Always be generous with your lube. And then on this O-ring over here as well. Can't push this one on first. There you go, that one's home. The Vaillant flow switch turbine comes with new pieces. The clips that hold it in place, but I want to just reuse the existing ones because they're in good condition and keep the other ones as spare. Right, that's in. Whilst it's out of the way, let's get the gas connected back up. That goes there. Connect all these cables back up. Okay, brilliant. Fresh cut, so it's not only Worcesters that cut you, anything bloody metal cuts you. Okay, and that's in. That's in, and now always try to pull it apart. That's solid. And now this one goes in. And done. There we have it, guys. Okay, I can hear water backfilling into the water heater. Moment of truth. Did I balls it up? We're back on. There we go. Yep. Water is back on, no leaks. Not that it should be anyway. Let's turn the gas back on and get some LDF. Okay, LDF. Hot water tap on, 58 degrees, there you go, boom. Flame on, guys, flame on. We're in action, we are back in action. Just to confirm, this is actually for my own future knowledge as well. I want to know what the reading for that PCB should be when the flow turbine is actually working. All I know that the turbine will cause the voltage to be different now, but by how much, I don't know. Let's check. Okay. Between grey and white, when it's standing idle, it's 17 volts. Between grey and pink, nothing. And then between white and pink, when standing idle, 17 volts. And then with the hot water running, between grey and white, still 17 volts. But now between grey and pink, 7 volts, 6.97 volts. And between white and pink, 10 to 11 volts. So there is a difference now. As you can see, that's working now. This PCB looks the same like it's the one that's in one of those glowworm boilers. Let's close the cover back off. Make sure all the cables are safe and sound. And it's now Friday. At least hot water is restored. That's the main thing. Let's carry out our fags. So, carry out the fags. Inlet working pressure, there it is, and burner pressure. Not going to fit. My trusty little favourite setup. It's a Premier, I think Regin also do it, little ratchet. I know I've got the Weiro one, but this one I like to keep it as a dedicated Vaillant one. And let's go to burner pressure. There we go. Boiler on. 7 millibars. That's perfect. Yeah, I don't know what the readings should be on the carbon monoxide, carbon dioxide. All I'm really looking at is my ratio. As long as that's like, below 0.004, I'm happy, and carbon monoxide, obviously below 200, I'm happy. So that's on maximum rate, 27 parts per million on CO, and my ratio 0.007. I'm happy, job done. Let's put the cap back on. Straight away, flame on. So I hope this video was useful to you. You saw how I diagnosed the issue. I used my multimeter to prove there was no change of voltage with the old damaged flow turbine. And when I put the new flow turbine in, you could see that the voltage is changed. And looking at the manufacturing instructions after I did the work, I looked at it last night, the flow turbine works on 18 volts. So it should be between 17 to 18 volts present between the grey and the white. I hope I'm saying this right from memory, at all times. And then when the flow turbine spins, 7 to 8 volts go to one part of the connection, and then 10 to 11 goes to the other part of the connection. This is how the PCB recognizes that there is a demand for hot water. The job went well, and the customer was over the moon that he had hot water restored just in time for the weekend. All my tools that I use are listed on my Amazon web shop. Links are in the description below, and as usual guys, please like, share, subscribe. I'd really appreciate it, and always leave comments and feedback on how you would have done the job different. If there's a way that I should have made it, probably should have done the job I don't know, if I could have made the job any better. And yeah, you know, we're all in it together to learn from each other. And you know the drill, guys. Please kindly like, share, subscribe. I'd really appreciate it. And every little helps, as you know. And until next time, live long and prosper. And I will see you all in the next video. Over and out.